All right, what's everybody? We're talking about line of best fit, which basically just means the line that makes the best guesses. I hope if you look at this picture, you see kind of the image we were talking about before we started. Let me hit this button. There we go. So, looking at this picture, you see all of these little dots. This is the data, okay? All of these little dots is the real actual data that we have, and then you see this line that goes through the middle of the data. That line is the computer doing its best to make a perfect prediction. Now, our goal for line of best fit is to do 3 steps. Step number 1, we need to use the data that we have. Basically, that means we need to get some dots into DESMOS. Okay? Write this down. Come on. Like I said, very important day of notes. Step number 2, after we get the data in there, we need to get the line into DESMOS. This is the line that goes perfectly through all the dots. And then step number 3, all right? I'm going to put the money sign by step number 3 because this is where you make all of your money. This is your prediction. This is where you see the future. This is where you use exact mathematics to make an exact prediction. Okay, this is where the government, this is where Google, this is where Pepsi pays you money. If you don't think Amazon's got 1,000 people doing this kind of math, then you're just wrong, right? That's how Amazon's so good at being so efficient. They got mathematicians everywhere making these predictions. So, here's what we want to do. We want to start by getting data into our DESMOS. Let's read question number 1. It says, a student who waits on tables at a restaurant record the cost of meals and the tip left by single diners. So we have the meal cost at the top here. This is how much the meal costs. $4.75, $6.84. All of these things are how much the meal costs. And then they also kept track of how much did the person tip. So, right here, we have all of those tip information. That's 2 different types of data. So we're always going to do the top one as the X and the bottom one as the Y. A little hard to see the Y on the pink, so I'll do it in black. So in DESMOS, we want to get this information, the X's and the Y's, into the table. This is one of those things I'm about to come around and check that you have typed in. So lock it in and be ready to type. In order to type in table, I'll give you 2 options. On the notes, it says enter data into table. It says plus, comma, table. So, do you see this little plus sign up here? If you press the little plus sign, guess what one of your options is? Table. And then you can type in your table. I'll give you another way to get a table. If you literally type T-A-B-L-E, if you just type the word table, it will give you a table. So you have 2 options now. You can either press the plus table, or you can just type T-A-B-L-E, and it will give you a table. Now the X's, very important. The X's go up and down on DESMOS. On our paper, the X's go side to side. So you have to kind of twist the table a little bit. Make sure all of the top numbers go in the X column. So I'm going to type this in, 4.75. No money signs, just numbers. DESMOS doesn't need to know if it's money or not. DESMOS just needs to know the numbers. Enter 6.84. Enter. The next top number is 12.52. Enter. 20.42. Again, I'm going to come around and check this on your screen in just a second. Make sure you have it typed in perfectly. 0.50. Now we're on to the Y's, and we're doing the other one. Make sure it's in there correctly. 3.00, and 1.00. I always double check 4.75, 6 point, oh, almost had a little typo there, but I got it, 1552, okay, got it. Okay, my numbers look perfect. They perfectly match the X's and the Y's. Any issues? Is there anybody who's saying my table doesn't look right, I can't get the stuff in? Anybody having any problems? Everybody's feeling pretty good. Okay, now, if you look, and if I go home, I see 3 of the dots, but I don't see the other 3. Yeah. And of course, I could zoom out, but when it comes to this information, and when it comes to math, and when it comes to presenting your data, you need to show your data to a CEO and say, look, this data is really good. And if you show him a picture that looks like this, he's going to say, I don't know what the heck I'm looking at. Okay? There is a button on DESMOS, and you just click it, and it gives you the perfect zoom every time. It is a magnifying glass. Does anybody see the magnifying glass on their computer? Yeah. Where is it? Right there on the left side. Here it is. Look at the screen. Look at my mouse. Do you see this magnifying glass? If you click it, it'll give you the perfect zoom every time. And not only is it a perfect zoom, it is a more complicated zoom than you know how to do. Because look, it has 0, 10, 20. We're counting by tens in the X direction. It has 0, 2, 4. We're counting by twos in the Y direction. So even if you tell yourself, I'm just going to scroll around and do a zoom, you still cannot get a good zoom like if you just press one button and it's perfect every time. And if you need to look around, it comes back, you press it, it's perfect. Okay? This button, it goes away when it's already perfect. Now you move it, not perfect, you press it, it's perfect. This is one of the big secrets to students who pay attention and students who don't. Does everybody see the magnifying glass? Raise your hand if you see the magnifying glass. Diego, you know where it is? Raise your hand. You got it? Major, you good? Major! Major's feeling a little snoozy today. All right. Now that we're this far, now that we have our nice dots, step 1, the data is complete. We have the data into our DESMOS. Step number 2, we need to get the line into DESMOS. And I'll be honest with you, this is when it starts to feel very complicated, but trust me, it's not supposed to be very complicated. Look up on the wall up there. It says y equals mx plus b. I'll write it on my paper as well. Y equals mx plus b. Do you remember y equals mx plus b? It's called slope-intercept form, and it's just the equation of a line. And so, if we want to make a line, we're going to write y equals mx plus b. Now, if my job was to make the perfect line, it would be very hard, right? Let's say I try y equals, and let me try 2x plus 1. Does this red line look like it goes through the purple very well? Not even close, right? And if I keep trying to edit this, it's going to be very hard for me to get this line. It's going to take me forever. Here's the good news. DESMOS can make the perfect line instantly. So how do we make DESMOS take the perfect line? First of all, think about it like this. Y equals mx plus b. Okay? Now on DESMOS, DESMOS is saying, I don't really know what the m is supposed to be. I don't really know what the b is supposed to be. So listen to me here. We need to make a few adjustments. We need to tell DESMOS, hey, this table with all the data, I need you to make a line based on the table. Give me a line that matches the table. And what you might notice is that our table uses x1 and y1. Now listen, please don't let these ones intimidate you. The only reason there's ones here is because when you get into really good and when you're trying to make $100,000 a year working for Amazon, instead of having one table, you're going to have multiple tables. So instead of having x1, y1, you might have x1, y1, x2, y2, another table called x4, y4. But for now, in Algebra 1, it's always going to be ones. That means down here where it says y equals mx plus b, we're going to go after the y and we're going to press 1. And now Desmos is going to say, oh, you're talking about the table. We're going to go after the x and we're going to press 1. And now Desmos is going to say, oh, now you're talking about the table. So Desmos is starting to figure this out. Desmos is taking x1, y1. It's starting to figure all this out. Now the last piece here, let's see here. What does it say? Scroll down. Oh, I don't know what's happening. I'm trying to zoom in for you guys, but it's not working. Here's what's going on. Desmos says x1 and y1 can't be defined. Okay, that makes sense. Here's what's happening. The equal sign is the last problem that we're having, because we're not trying to make an exact equation. We're still trying to make a prediction, which means we have to use estimates, which means we have to use guesses. So instead of using the equal sign, this is probably the craziest thing we're going to type all day, we're going to backspace the equal sign, and we're going to do the squiggly line. Now, first of all, why the squiggly line? I want you to think of the squiggly line like it's somebody doing like a right? We've got our table, and we want our line to be pretty good, right? We don't need the equals because it might not be equals. We need the squiggly line. Now, where can you find the squiggly line on your keyboard? Anybody find it on the keyboard? Yeah. You can find it, I'll move my thing here, right here by the escape key. By the escape, by the tab, by the 1, you have to press shift. It is the squiggly line right here on the Chromebook. Now, once we've done that, we have y1 from the table, mx1 from the table plus b. Now, Desmos is recognizing, oh snap, I know exactly what you're talking about. You want a line that goes through all the dots. Now, first thing, this line does not have to go through the purple dots. Notice that the blue line is not touching every single dot. It's not a zigzag line, okay? It's doing its best to make a prediction. Sometimes in real life, things don't work exact. You still have to make a prediction anyways. Down here, you have all of these stats, okay? And so let's talk about what these stats are. First of all, residuals, useless. We don't care about residuals. The r squared value is nice. The r squared value is the confidence that Desmos has. So, right now, this is how Desmos, how confident is Desmos? This 98 is like 98%. Desmos feels 98% confident that it's going to make you the perfect prediction, which is pretty good, okay? If you're doing a question and you have anything less than 90%, it is not right. When you take a science class, maybe you take physics in college, and you have to do an experiment they'll tell you if this confidence is not 95%, then it's not a good experiment and you made a mistake and your data is not good. So you have to be about 90%. Right now we're 98%. Let me show you what happens. What if I accidentally, instead of 0.90, what if I make it just a straight up 90, right? Now this dot is way in the wrong spot. Now Desmos is trying to make a good line, and this line is not very good. And look how confident Desmos is, 10%, right? So if you have a bad R squared, it probably means your data is wrong. It probably means you made a mistake. As soon as I make this 90 into a 0.90, it's going to fix the dot. Desmos is going to say, oh, thank you. That makes more sense. Now I'm 98% confident again. Okay, all of that being said, we have our line figured out, and it really wasn't that hard. It's the same equation every time. It's right here on your paper, and it's right there on the board. See it over there by Carla, by Major. At the top it says linear, y1, squiggly line, mx1 plus b. It's just y equals mx plus b with a squiggly line and two little ones. Okay, now I hope on your computer screen you have all of these dots and the line. Miss East is coming around. She's looking to see that you have all of these dots and the line. Now the last thing we haven't talked about is the parameters. What are these parameters? First of all, the word parameter sounds complicated. Trust me, it ain't really that bad. It's just the M and the B. So remember, Desmos is trying to give you the equation that perfectly goes through these dots, and so the M and B are the numbers that you need to go directly through these dots. So question number 1, it says, what is the equation for these dots? I know I've been talking a lot. Here comes some actual writing. We're going to try to write the equation, which is going to be y equals mx plus b. So up here on the line, y equals, the m needs to be replaced with the actual number m. That number m is down, oh, I'm sorry. It's right on the board in the red as well. Right here, the m is 0 point, and it's all these decimal places. In my class, we're going 2 decimal places, which means you might have to round. Not even joking, this rounding is the only math, like the actual math that you have to do, is to round numbers. So, how does rounding work? If you have a 9, are you rounding up or down? Up. If you have an 8, 7, 6, what about 5? Up. What about 4? Right. If you have a 4, then you're just going to stay the same. Same with a 3, same with a 2, same with a 1. Okay. So if we're looking for a 9, 8, 7, 6, 5, we're going up. So for the m, it is 0.15. Do we need to round up to 16? Yes, we need to go up to 16. 0.16. Right? That's just the m right there. Then we have the x. And up next is the b. The b needs to be replaced. So what is the b number for this question? It is negative 0.29. Do we need to round up to 30? Yes. So we're going to put negative 0.30. And again, the rounding is the only math you have to do. Everything else, type it in, type it in, type it in, type it in, answer. Now, I've been talking a ton. We've just done 90% of what we're learning today. Okay, we are pretty much done. I do want to point out that when you write down your answer here, you're not going to write down any of the ones because you're not a robot. We don't put ones after our letters. That's not how humans work. We're not going to put the squiggly line. We're going to use an equal sign because we're not robots. We're humans, and we use an equal sign. Now, so far, we have done the data, we have gotten the line, but we haven't made any money yet. We have not made a prediction. This is where Google's paying you the money. It says, if the next diner orders a meal that costs $10.50, how much tip should the waiter expect to receive? So, $10.50, is that the cost of the meal or is that the cost of the tip? Meal. This is the meal cost. It says it right here. $10.50 is the meal cost. Is the meal the X variable or the Y variable? The meal is the X variable. And so what we're going to do is we're going to have on here that the X is equal to $10.50. And again, if that probably for a few people just whoa, Mr. Collier, chill. $10.50 is a number that they give us in the question. It says it's a meal number, and meal is the X letter. So all we said was the X is $10.50. You just take the number, you take the letter, you put an equal sign in there. And when we do that, onto Desmos, X equals $10.50, it will give us a line, and we will now see where does our perfect predictor cross the data that we want, and it is right here. When the meal costs $10.50, how much is the tip? $1.34, round up, $1.35. The tip expected is $1.35. Okay, so far we did a question. It was on the line of best fit. And we made a line that then went through the data so that we could make a prediction. Now, flip it over for me. Stay with me. I said we've already learned 90% of what we need to learn. You got to trust me. Question number 3. It says, during the game, Dallas Cowboys punter was called upon to punt the ball 8 times. On one of these punts, the punter struck the ball on his own 30-yard line. The height, h, of the ball above the field in feet as a function of time in seconds can be partially modeled by the following table. Here's what happened. Dude punted the ball. And guess what happens when dude punts the ball? It goes up, and then it comes down. It's called gravity. Right? It's called gravity. Thank you. Exactly. So smart, Makai. Now, what we need to do is get this data in here, and I hope it looks like gravity. So, let's go to Desmos, delete, delete, delete. How do we get a table? You remind me. Plus table. Or you can just type T-A-B-L-E, and it'll show up. We're going to do all of the top ones as our X, and we're going to do all of the bottom ones as our Y. So, type this in. Again, we're going to come around and see that you're doing it. Make sure you get your decimals in there. 0, 0.6, 1.2, 1.8, 2.4, 3. Make sure you get all of this stuff in there. You're good to go. 250, 2856, 4310, 4612, 3712, 1760. Now we've got a few more decimals to type in this time. You have to type it perfect. Make sure, I always double check, even as a teacher, I make mistakes from time to time. I always try to catch them. I think my data is looking pretty good. Now that I've got the data in there, I need to press one more button so that I can see the data better. The magnifying glass. Even if you try to zoom it out, look how stupid this looks. This is not how a punter punts the ball. Hit the magnifying glass. This is how a punter punts the ball. The reason we hit the magnifying glass is, again, look at DESMOS. It goes 1, 2, 3. We're counting by 1, 2, 3. Or 20, 40, 60. Now we're going up by 20, up by 20, up by 20. That's why we need the magnifying glass. As of right now, does everybody have the magnifying glass? This nice picture of the curve. Everybody good on this? Promise. Okay. Now let's say I try my y equals mx plus b strategy. y1 squiggly mx1 plus b. If I try my perfect line and I try to get a line to go through these dots, if you were the NFL, and the NFL pays lots of mathematicians and lots of sports scientists to calculate things, if I told you, hey, my red graph is the shape of your punt. It's going to start at 21 feet in the air, and it's going to go up and 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 up, and the gravity that Makai mentioned doesn't exist. Does this red line look good? No. Look at the r squared. He's cooking over there. The r squared is the confidence. DESMOS is not confident. DESMOS says 11%. DESMOS knows this is a bad line. So delete this one. What we need instead is a curved line. Now this one is a little bit more complicated. Just like before, it is written at the top. It is also on the sideboard. It can be called a curve of best fit, or it can be called a quadratic. It's going to make a U shape, and it's very popular for anything that has to do with gravity. Now, we should know how to type in all of these symbols. Okay, at this point, it's on you to type them in. It says Y, 1, squiggly line, A, X, 1, shift 6, 2, plus B, X, 1, plus C. Now make sure you got every single piece here. Remember, that's on the paper, that's on the sideboard, and just type the letters in there. Now, how good does this curve look compared to our dots? Obviously, it looks really, really, really good, right? It looks extra, extra solid. I can see that my blue line is going right through all of my orange dots. How confident is DESMOS? 99% confident, right? DESMOS feels really, really good. Okay, so far, we got the dots, we got the line. Let's answer the questions here. It says, use DESMOS to obtain the quadratic regression. Okay, we did it. Round your answer to the nearest hundredth. So let's write down our equation now. It needs to be y1. And remember, we have A, B, C. So we're going to use the letter A and the letter B and the letter C. It's a little bit annoying because you have to write down some decimals, but that's all you have to do, right? You don't have to add numbers together. You just got to write down decimals. So let's do this. I want to write down the equation. I'm going to start with y, I don't need the 1, equals, I don't need the squiggly sign. Up next is A. What is the number for A? Negative 15.97. Do I need to go up to 98? Yes. Negative 15.98. And just like all year, you're going to start with the x squared. I don't need the 1. I need the x squared. Up next is B. B is 5288. Do I need to go up to 89? Yes. Again, this is not hard. 52.89. Because my 88 needs to round up. And the B gets a single x on it. Make sure that you're going from x squared to x. And up next is C. C is 2.553. Do I need to go up to 5.6? No. 2.55. And when it comes to C, I should have no x. Just like all year. X squared, x, no x. Just like when we did foiling. Just like when we did factoring. X squared, x, no x. This is our perfect line, and now we can make predictions. We can calculate what is the ball's height after 2 seconds in the air. I know the height after 1.8 seconds. I know the height after 2.4 seconds. But what about right here? What about after 2.0 seconds? Okay? All I need to do is either type x equals 2.0 or y equals 2.0. When it comes to these 2.0s, that is my time, which is an x, and so I need to type x equals 2.0, x equals 2.0, and if you look at this picture, I hope it makes sense. Here's the kicker. He kicks it. Higher, 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 higher. Here's 1 second. Higher, higher, higher. It gets to the top. Now it starts to go down. Here's 2 seconds. This is when we want to look. And then it starts going down, 3 seconds, and then it hits the ground. At 2 seconds, how high is the ball? 44.42. Round it up to 43. 44.43. 44.43 feet. And the last one here is C. It says, predict when the ball will reach its highest point from the ground. All right. How are we going to figure out when the ball gets the highest possible place? Now, if I look at my table, I can see that the highest spot is probably right here at 46.12. Now, the reason that they're going to pay a mathematician $100,000 a year is because obviously 46.12 is how high the ball went. But is that the highest possible place? If I go back to DESMOS, if I click on the curve, DESMOS will always give you interesting spots, right? This is how high the ball was when the guy kicked it. 2.5 feet off the ground. If you stand up and you kick a football, it's like 2.5 feet off the ground. Boom, right? It will also give you another gray dot over here, 3.3580. Guess what that is? That's when the ball hits the ground. So if the question said, how long until the ball hits the ground? It takes 3.35 seconds for the ball to hit the ground. Or I guess we would rotate up to 3.6. And it will also give you a dot at the very top so that you could tell what is the absolute peak. And so, what is the highest place that our ball ever gets? 46 46.33 feet in the air. 46.33 feet in the air. Now, the question even says predict when the ball will reach its highest point. And we have that information too. It's going to be at its highest point after 1.66 seconds. 1.66 seconds. So, here's what's up. This is really not that hard, but it is a lot of typing things in, and you have to know what you're going to do. You're going to recognize that the difficulty when we have a lot of practice tomorrow is you're like, okay, I did the table. What the heck am I supposed to do next, right? So you got to keep track of get the table, get the line, make the prediction. Get the table, get the line, get the prediction. The reason you're making so much money is because once you get the data in the computer, once you get the line in the computer, now you can predict a ton of things, right? You can figure out exactly how high it is after half a second, exactly how high it is after this long. You can start to collect lots of data and say, I know how to predict the farthest possible kick. Here's the trajectory that we want to find, right? Okay, we have about 5 minutes left in class, about 10 minutes left in class. We're going to do question number 4, and I'm going to go about 10 times faster because we've been going really slow. I'm going to clear out the rest of this stuff, follow along, get one more question, and we won't have classwork today. First of all, I got a table. I need to get the table into DESMOS. So I'm going to do it this way, T-A-B-L-E. I'm going to type the numbers 0, 3, 6, 9, 12. Then I'm going to go back, and I'm going to get my Y's in there. 5, 28, 86, 180, 310. Now I've got all my data. I'm going to double check. 0, 3, 6, 9, 12, 5, 28, 86, 180, 310. I'm going to hit the zoom button. And now the zoom's looking really good. Look at how different it is. It goes from 0 to 15. It goes from 0 to 400. I don't care how much you try. If you try to zoom out, this does not look good. Hit the magnifying glass. Now it looks perfect. Now it looks perfect. Okay, I need to get the line in there. If you want, you can try both. You can try the line and the curve, but this question straight up says curve. So we don't care about the line, we want to do the curve. In Algebra 1, it's pretty much just going to tell you which one you're supposed to use. In Algebra 2, you kind of have to pick. Makai is doing so good at this stuff. I'm very proud of you today, man. You're doing a great job. Y1, squiggly, AX1, shift 6, 2, plus BX1 plus C. Again, I know it's a little complicated. It's on your paper. It's on the board. You just got to type it in, okay? Look at the R squared value. Make sure it's at least 95. And this is a straight up perfect 1. That's like a 100%. DESMOS feels literally perfectly confident that this is going to be excellent. We have the parameters A, B, C. That's going to help us with our equation. And if I read this here, it says write the equation. So I'm going to use ABC. First of all, y equals A. And A needs to be 1.98, 1.98. And then you put the x squared on there. You okay? Okay. Up next is going to be plus the b. And the b needs to be 1.59. 1.59. And then we're going to put an x on the b. And then we're going to finish with the c. And the c is 5.11. It's not going to round up. And so here's the equation that I got. Y equals 1.98x squared, 1.59x, and 5.11. Make sure no ones, right? There's not a little 1, there's not a little 1, there's not a little 1. Make sure no squiggly line. Make sure you got x squared, x, no x. And now, we still haven't made any money yet, but now we're all set up. We have this beautiful graph that goes through the dots. We can predict anything we want. The first one says, predict it when x equals 7. So I'm just going to go on DESMOS and type x equals 7. Anybody get that answer yet? 113.47, okay. 113.47, 113 and 47. Is that not what you got? Up next is x equals negative 15. X equals negative 15. How come I can't see that? So you might have to look around a little bit. You might have to look around a little bit. I see it right here. And it says 427.68. Are we rounding to 69? Yes. 400. I already forgot. 427.69. All right. That is linear regression, line of best fit, curve of best fit. It's a little bit crazy, but get the data in there, get the line in there, or the curve, make a prediction. All right, I'm into the notes, pretty good.